Okay. So the next reaction that we're going to talk about, period three elements, that is the reaction of the elements with water. It's kind of sad because it says reactions of period three elements with water, and the only thing that you're supposed to know are the reactions of sodium and magnesium, which you've actually would have studied in your inorganic chemistry in IGCSE itself. So for what it's worth. So reactions of period three elements with water. Yeah. Reaction of period three elements with water. So only sodium and magnesium. Okay, it says very clearly sodium and magnesium only. So we know the reaction of sodium with water, right? So you get the metal hydroxide and hydrogen gas. And because it produces the alkali, that's the reason why group 1 metals are called as the alkali metals, isn't it? So sodium reacts very vigorously with water to produce an alkaline solution. You get sodium hydroxide, plus you get hydrogen gas. Okay, so you must have seen YouTube videos, or if you were lucky, you would have seen this in chemistry laboratories. Okay, in schools. I can put a couple of links to a couple of videos right at the end so that you can have a look at the videos yourselves if you haven't seen it yet. Okay, so what you see is that the reaction is highly exothermic. So the reaction is vigorous. Okay, the reaction is very vigorous. It's pretty fast. Okay, strong fizzing. Okay, of hydrogen. Strong fizzing is seen. So you'll see a lot of bubbles. Okay, that basically means when the bubbles come, right? I mean, it's obviously Newton's third law, right? When bubbles are released so quick, what happens is they propel the solid forward. They push the sodium metal forward. So you'll find that the sodium metal is acting crazy and runs all over the place. Yeah. So the sodium metal shoots across the surface of water. Okay, and melts into a tiny ball. So you'll find that it is actually melting into a tiny ball and then getting smaller and smaller as it gets used up, because the reaction is exothermic. Not just that, the reaction is exothermic, and the heat energy produces enough to melt sodium. That also is an indicator of how low the melting point of sodium actually is. Now, magnesium is slightly weird, because magnesium solid, okay, does react with cold water, okay, water at room temperature when we say cold water. And then this produces magnesium hydroxide, okay, an aqueous solution of magnesium hydroxide and hydrogen. Okay, but you find that the reaction is rather slow. The reaction is slow. How slow are we talking about? What happens is a few bubbles of hydrogen gas, colorless bubbles of hydrogen gas, are seen building on the surface of the metal, okay, after several minutes. So you wait for like about 10-15 minutes, you find that because the sodium is heavy, it kind of sinks down to the bottom of the water. And there you'll find that magnesium, on the surface of the magnesium metal, there are tiny bubbles that build. Now, if you're lucky and enough bubbles build on the surface, that kind of makes it buoyant, and the magnesium will rise to the surface. Okay, it's like how you kind of hold on to something that is inflatable and then you are inside the water. So the inflatable kind of makes you come up. So it makes you buoyant. So that's what happens to the magnesium with the hydrogen bubbles attached to it. But what happens is, so the hydrogen comes up, so the magnesium with the hydrogen comes up, you will find that the hydrogen gas escapes, magnesium again, no longer buoyant, it goes down. Okay, so you kind of find it dancing up and down, but then it's a very, very slow dance that no one honestly has any time for. Okay, so the reaction is slow, few bubbles are seen, etc., etc., etc. But what about the magnesium hydroxide itself? Magnesium hydroxide isn't highly soluble in water. Okay, so the magnesium hydroxide is not highly soluble in water. All right, soluble in water. So it's seen as a white suspension. I mean, yeah, it kind of turns a whitish color, right? A whitish color, rather than being a clear solution if it dissolves. Okay. That's the reason why the magnesium hydroxide is a pretty weak alkali. Its pH is around 9. Okay, pH is around 9. In fact, a solution of magnesium hydroxide is given to treat acidity. It's called milk of magnesia. All right, that's the reason, because its pH is pretty low for an alkali. It's pretty weak. While sodium hydroxide is a strong alkali, pH 13, 14. Okay, so that's because it's highly soluble. So seen as a white suspension. However, magnesium reacts vigorously. It in fact burns. Okay, burns when you expose it to steam. Obviously, steam, temperature above 100 degrees Celsius. So magnesium reacts vigorously with steam, but the products are white solid magnesium oxide and hydrogen. You don't get the hydroxide. Okay, so if you expose magnesium metal to steam, then the reaction is pretty vigorous. It even burns with a white flame, but you don't get the hydroxide. You get the oxide, which is a white solid. And hydrogen, I think that is balanced. Oh, this one just needs to be balanced. And the earlier one as well, right? Yeah, the earlier one as well. So you basically have 2, 2, and 2. That was balanced. Okay, so those are the reactions of the period 3 elements with water. But as I told you, it's only sodium and magnesium.